The James Webb Space Telescope has peered further into the cosmos than any instrument in history. Its findings have compelled astronomers to question the very bedrock of our cosmic knowledge. In this quiet meditation, we will explore why the telescope's observations are not merely surprising, they are deeply unsettling for the scientists who have dedicated their lives to studying the universe. As we begin this shared journey into cosmic mysteries, it is remarkable to think of us all, watching from different corners of the world at different moments in time. The images that follow are here to guide you. You are also welcome to simply listen, close your eyes, and allow your mind to drift through the immense quiet of space. It is my hope that you will stay for the entirety of these mind-altering revelations, yet there is no expectation to do so if sleep should find you along the way. Let your consciousness wander through this intricate web of cosmic discovery. Our exploration into the unnerving elegance of what lies in the deep past begins now. Picture yourself standing in a familiar place on a clear evening, looking upward toward the canopy of stars. Those faint embers of light appear serene, ageless, and constant. For millennia, humanity gazed upon that very same sky, confident in its understanding of what it was seeing. We held beliefs about the universe's scale, its age, and the story of its origins. The James Webb Space Telescope, however, has fractured those comfortable certainties. It has done so in a way that should give us all reason to contemplate what other truths we may have mistaken. When Webb first focused its golden segments on the heavens, researchers anticipated seeing confirmations of their predictions. They expected to witness a nascent universe, slowly assembling its initial structures. They foresaw small, uncomplicated galaxies that would gradually expand over eons. Scientists believed they would find a cosmos that adhered to the established principles of our meticulously developed theories. Instead, Webb returned data that has caused astronomers to lose sleep, examining their screens in a state of profound disbelief. The telescope gazed back in time more than 13 billion years. It looked to an era when the universe should have been in its cosmic infancy. What it witnessed in that distant past defies our current explanations. In a place where darkness and simplicity were expected, Webb observed brilliant light and bewildering complexity. Where tiny, primitive structures should have been just starting to coalesce, it found enormous, fully developed galaxies that have no right to exist. Let the significance of this discovery settle for a moment. Imagine an archaeologist excavating an ancient settlement. They expect to find rudimentary stone implements, but instead unearth a sophisticated mechanical clock. This is the degree of impossibility that cosmologists are now confronting. The universe seems to have been significantly more developed at a much earlier stage than our physics permits. Webb identified galaxies that had already formed when the cosmos was merely a few 100 million years old. While that may seem like a vast stretch of time, on a cosmic scale, it is comparable to discovering a mature, old-growth forest that appeared overnight. These galaxies are home to billions of stars. They contain colossal black holes, and they exhibit intricate structures that ought to have required many billions of years to form. Yet, they are present, shining with incredible luminosity in the primordial dark, challenging our fundamental grasp of cosmic mechanics. The unsettling discoveries, however, do not end with these galaxies. Webb revealed something even more troubling when it surveyed the sheer quantity of galaxies in regions previously thought to be well charted. Earlier telescopes had taken a census of the cosmic population, and that count was considered largely complete. When Webb examined those same patches of sky, it uncovered 10 times the number of galaxies that anyone had anticipated. 10 times more. This is not a minor discrepancy in measurement. It represents a fundamental misinterpretation of reality itself. Consider what it would be like to believe your town contained 100 buildings, only to have someone with a clearer vantage point reveal that there are actually 1,000. You would begin to reevaluate everything you thought you knew about your own home. This is precisely the situation cosmology faces today. The universe is substantially more populated, more dynamic, and more enigmatic than we ever conceived. These findings have given rise to what scientists term the too much too early problem. The primordial universe was generating an excess of light, creating an overabundance of stars, and assembling too many galaxies in an impossibly short period. It is like observing a construction team erect an entire city in a single day when you know the process should take decades. The calculations simply do not align with our existing comprehension of physics. Think about the consequences of this. If our most foundational ideas about cosmic development are incorrect, what other phenomena might we have misunderstood? If galaxies can materialize with impossible speed and the universe can be unexpectedly dense, then perhaps the very fabric of space-time behaves in ways we have not yet considered. It could mean there are forces at play that remain undiscovered. Perhaps there are laws of physics yet to be written, and possibilities we have not even begun to imagine. Webb also located supermassive black holes residing in the hearts of these ancient galaxies. These cosmic behemoths possess masses millions or even billions of times greater than that of our own sun. They are actively consuming the material around them, emitting energy that can outshine their entire host galaxies. But the truly disconcerting detail is this. These black holes are present at a time when the universe was supposedly too young for them to have formed. Black holes are born from the collapse of massive dying stars, yet these massive stars require time to live out their life cycles and reach their end. Even the largest stars burn for millions of years before they finally detonate. The resulting black holes then need additional time to accrete surrounding matter and grow. This entire sequence should require billions of years to produce the giants that Webb has observed. Nevertheless, they are there, fully grown, and actively feeding within a cosmos that is only a few 100 million years old. The situation is analogous to finding a tree with 1,000 growth rings in a forest that was planted just last year. The chronology is incoherent, the physics is untenable, and scientists are beginning to question whether their entire understanding of universal evolution might be deeply flawed. Some researchers are now suggesting that these early galaxies and black holes came into being through processes we do not yet comprehend. It is possible that dark matter acts in ways different from our current models. Maybe the early universe was far denser and more efficient at building large structures. Perhaps there are entire mechanisms of cosmic formation that have yet to be revealed. These, however, are merely hypotheses, not firm explanations. The observations themselves are undeniable. Our theories are now in a race to adapt. The most profoundly troubling part of Webb's discoveries is not simply that they defy our predictions. The core implication is that the universe might be governed by principles we don't yet comprehend. For centuries, science has advanced through a trusted cycle of observing nature, creating theories to explain what we see, and then testing those theories with more observation. This method has been extraordinarily fruitful, yielding everything from electricity and space travel to the internet. But the observations from Webb suggest this entire approach may have inherent limits. It's possible the cosmos contains phenomena so foreign to our experience, so different from anything reproducible in a laboratory, that our current methods of understanding are simply inadequate. We could be like ants trying to grasp nuclear physics. We can see the effects, but the underlying reality might forever be beyond our grasp. This situation creates a profound existential question for cosmology. If our fundamental understanding of how the universe functions is wrong, what can we truly trust? If galaxies can form impossibly fast and black holes can grow impossibly large, then perhaps space and time themselves operate differently than we have long believed. It could be that causality adheres to principles we haven't yet found, or that reality itself is far stranger than we can imagine. Webb has also revealed that the cosmic web, the largest known structure in the universe, might be far more complex than we once realized. This web is made of dark matter filaments connecting galaxy clusters over hundreds of millions of light years. Previous observations indicated this structure formed gradually across billions of years, but Webb's data points to massive structures existing much earlier than they should have. The telescope detected galaxy clusters and superclusters that were already formed when the universe was young. These structures contain thousands of galaxies held together by gravity, spanning distances that light takes millions of years to cross. Building such enormous formations should require vast amounts of time for gravity to pull matter together across such cosmic distances. Yet Webb found them already assembled in the early universe, as if someone had accelerated cosmic evolution. This discovery forces us to confront difficult questions about the nature of time itself. Perhaps time doesn't flow at a constant rate throughout the cosmos. Maybe the early universe experienced time differently than we do today. It's possible the expansion of space affects not just distances, but the very rate at which events unfold. These possibilities lead us into territory where science and philosophy converge, where our very understanding of reality comes into question. As we drift deeper into these cosmic mysteries, it's worth remembering we are witnessing a pivotal moment in human understanding. We are living through a time when our most fundamental assumptions about existence are being challenged by direct observation. The universe is revealing itself to be stranger, more complex, and more mysterious than we ever dared to imagine. But perhaps the most unsettling discovery of all is still on the horizon. Webb's observations suggest that what we can see might only be a tiny fraction of what actually exists. The observable universe, that sphere of space from which light has had time to reach us, might contain trillions of galaxies instead of the hundreds of billions we previously estimated. And beyond that observable boundary lies the vast unknown, stretching possibly to infinity, filled with structures and phenomena we may never be able to study. The implications of this ripple through everything we thought we understood about existence itself. If Webb can detect galaxies that shouldn't exist, formed through processes we can't explain, what does this say about the reliability of scientific knowledge? We have built our understanding of the cosmos on careful observations and mathematical models, layer upon layer of theory tested against reality. But Webb's discoveries suggest that reality might be fundamentally different from what our theories predict. Think about how we measure cosmic distances and ages. We use the light from distant objects as cosmic archaeologists, reading the history written in starlight that has traveled for billions of years to reach us. The farther we look, the further back in time we see. This method has been the backbone of cosmology for decades. But Webb's observations suggest that the story this light tells might be incomplete or even misleading. When Webb detected fully formed galaxies existing just a few 100 million years after the Big Bang, it wasn't just finding objects that were surprisingly old. It was discovering that the universe's timeline might be fundamentally wrong. These galaxies show signs of stellar populations that should have taken billions of years to develop. They contain elements forged in multiple generations of stars, elements that require time to be created, dispersed, and incorporated into new stellar systems. The chemical signatures Webb detected in these ancient galaxies tell a story of rapid cosmic evolution that defies our understanding of stellar life cycles. Heavy elements like carbon, oxygen, and iron don't appear instantly. They must be forged in the nuclear furnaces of massive stars, then scattered through space when those stars explode as supernovas. This process should unfold over many stellar generations, each one enriching the cosmos with heavier elements than the last. Yet, Webb found galaxies rich in these heavy elements existing when the universe was supposedly too young for this enrichment process to have occurred. It's like finding a library filled with volumes of human history in a civilization that was supposedly founded yesterday. The books shouldn't exist because there hasn't been time to live the experiences they describe. This discovery forces us to question whether time itself behaves the way we think it does on cosmic scales. Perhaps the early universe operated under different physical laws than those we observe today. Maybe the rate of stellar evolution was dramatically different in the dense, energetic environment of the young cosmos. Perhaps there are mechanisms of cosmic development that we haven't yet discovered or imagined. Webb also revealed that these impossible galaxies aren't scattered randomly throughout the early universe. They appear to be connected by vast structures, primitive versions of the cosmic web that shouldn't have had time to form. The telescope detected filaments of matter stretching across millions of light years, connecting galaxy clusters that existed when the cosmos was supposedly still a chaotic soup of particles and energy. The emergence of such vast cosmic structures is thought to depend on dark matter, which must first coalesce under its own gravity to form a kind of scaffolding that then draws in ordinary matter. According to our models, this should be a slow, deliberate process, one where gravity takes billions of years to arrange material across these immense scales. What the Webb telescope found, however, was evidence of this kind of organized cosmic architecture already in place, almost immediately after the Big Bang. It was as if the universe had somehow bypassed its formative years, leaping directly into a more mature phase. These findings directly challenge our very conception of dark matter itself. This enigmatic substance is believed to constitute about 85% of all matter in the cosmos, yet our only confirmation of its existence comes from its gravitational influence. We have never directly observed a particle of dark matter, nor have we ever managed to capture one in a laboratory setting, leaving its true nature a profound mystery. Our theories concerning dark matter are built upon its apparent behavior on the grandest scales, where it seems to pull galaxies together and give shape to the cosmic web. But Webb's discoveries hint that dark matter may behave in ways we had not anticipated, particularly in the universe's earliest moments. It's possible that it clumps together far more efficiently under specific primordial conditions. It may also interact with ordinary matter through forces we have yet to detect. There could even be different varieties of dark matter, each governed by its own unique set of physical laws. Such possibilities are opening up entirely new avenues in physics that we are only now beginning to chart. The telescope's powerful infrared sight has also uncovered that a great number of these early galaxies are enveloped in thick shrouds of cosmic dust, which made them completely invisible to previous observatories. This dust has the effect of absorbing and scattering visible light, concealing the galaxies behind opaque curtains. Infrared light, however, can pass through these dusty cocoons, unveiling the stellar nurseries that lie hidden inside. Webb's data revealed that star formation in the early universe was dramatically more energetic than any model had ever predicted. Some of these young galaxies were found to be producing stars at rates hundreds of times greater than anything observed in the modern cosmos. This level of intense star birth presents its own set of confounding problems. Stars need gas to form, and that gas has to be cool enough for gravity to begin compressing it into stellar cores. Yet, such rapid star formation ought to heat the surrounding gas, which should, in turn, inhibit the creation of new stars. It is a self-regulating mechanism that should naturally place a limit on the process. Webb, however, found galaxies that had somehow surmounted this physical barrier, continuing to generate stars at an astonishing pace without depleting their fuel or overheating their environments. The energy being released by these star-forming galaxies is simply staggering. Some of the objects Webb has detected are emitting light equivalent to trillions of our suns, all concentrated within regions smaller than our own Milky Way galaxy. This degree of energy output should have profound consequences for the surrounding cosmic neighborhood, heating gas across vast expanses of space and suppressing the formation of any nearby galaxies. And yet, Webb observed these cosmic furnaces existing alongside other galaxies that were also actively forming stars, as if the established rules of cosmic feedback and regulation were simply not in effect. Perhaps the most unsettling implication of all comes from what Webb's discoveries suggest about our own position in the cosmic timeline. For a long time, we have operated under the assumption that we inhabit a universe that is approximately 14 billion years old, with the majority of its significant structures having formed over the last several billion years. This timeline situates humanity in a relatively mature cosmos, a universe where the principal stages of cosmic evolution are well advanced but not entirely concluded. But if the observations from Webb are accurate, if truly massive structures and complex galaxies were able to form almost right after the Big Bang, then we may be living in a universe that is far more developed than its age would suggest. It could be that the main era of cosmic evolution occurred within the first billion years, and everything that has happened since has been a long, slow descent toward cosmic senescence. It's possible we are not spectators to the universe's youth and middle age, but rather witnesses to its twilight. This idea reframes our entire perception of cosmic history and our place within that story. Instead of residing in a dynamic, evolving universe filled with potential for future growth, we might occupy a cosmos that has already moved past its most creative and energetic period. The galaxies, stars, and structures we observe around us today could be ancient relics from a far more spectacular epoch, like fading echoes of cosmic events we can never see firsthand. Webb's findings also bring up disquieting questions about the very nature of scientific observation. For centuries, our work has been based on the premise that looking deeper into space gives us an accurate view of cosmic history. We have placed our trust in the idea that the light journeying to us from distant galaxies carries reliable information about the conditions that existed at the moment that light was emitted. But what if this fundamental assumption is flawed? What if the act of observing the universe through electromagnetic radiation provides us with an incomplete or even distorted picture of reality? It's conceivable that there are aspects of cosmic evolution that leave no trace in the light we are able to detect. The universe might operate according to principles that are fundamentally invisible to our current methods of inquiry. The impossible discoveries made by Webb suggest that our understanding of the cosmos may be constructed on foundations that are much less firm than we once believed. As you reflect on these possibilities, it's important to recognize that you are witnessing science at a critical juncture. We are now confronted with observations that challenge our most fundamental assumptions about the workings of the universe. The comfortable certainties that have guided cosmology for decades are now beginning to dissolve in the light of Webb's revelations. We are stepping into an era where the cosmos seems stranger and more mysterious than we ever thought possible, an era where our most advanced theories are struggling to account for what we can now plainly see. The universe that Webb has unveiled is not the orderly, predictable cosmos we thought we understood. It is a place where galaxies assemble with impossible speed, where black holes expand to impossible sizes, and where structures span impossible distances in what seem like impossible timeframes. It appears to be a universe that functions by rules we do not yet comprehend, following patterns we cannot predict, and evolving in ways that contradict our deepest scientific intuitions. And perhaps the most unsettling realization of all is that Webb's discoveries suggest this strange, seemingly impossible universe is the very one we have been living in this whole time. The comforting illusion of cosmic understanding has been shattered, exposing a reality far more complex and mysterious than we ever dared to imagine. We are now standing at the threshold of a new age in astronomy. We find ourselves in a domain where inquiries vastly outnumber our explanations, a place where every new observation has the potential to overturn decades of carefully constructed theory. It is a cosmos that seems determined to remain just beyond the limits of our total comprehension. The significance of these discoveries reaches far beyond the confines of academic debate. When the Webb telescope detected galaxies containing billions of stars in cosmic regions where only millions were predicted to be, the finding was more than a simple matter of a higher-than-expected count. This was a revelation that the universe may operate on principles that make our present understanding entirely obsolete. Such observations force us to entertain the possibility that everything we believed we knew about cosmic evolution could be fundamentally incorrect. Let us consider what occurs when a theory is developed using incomplete information. For many years, astronomers built their models of cosmic development with the limited data they could gather from ground-based telescopes and earlier space observatories. They devised elegant mathematical frameworks to describe how matter aggregates under the force of gravity, how stars ignite from collapsing clouds of gas, and how galaxies merge and mature over eons. For a time, these theories appeared to work with remarkable success, accounting for most observations and making accurate predictions about what more advanced telescopes might one day see. But the infrared vision of the Webb telescope has now shown that these very theories were constructed upon a foundation of missing data. The telescope is capable of peering through cosmic dust that had previously hidden entire populations of galaxies from view. It can also capture light that has been stretched by the expansion of the universe into wavelengths that are invisible to human eyes and to prior instruments. What once looked like empty expanses of space are now revealed to be teeming with galactic structures that were, until this moment, simply unseen. The sheer quantity of these newly discovered galaxies presents what scientists refer to as an accounting problem. A notable discrepancy arises when you tally all the matter that our models say should exist based on Big Bang nucleosynthesis and observations of the cosmic microwave background, and then contrast that figure with what Webb is actually detecting. There seems to be substantially more organized matter in the form of stars and galaxies than our frameworks predicted could have formed by this point in the universe's history. This disparity suggests one of two things. Either our comprehension of the Big Bang is incomplete, or matter assembles into complex structures with an efficiency far greater than we ever imagined. Both of these possibilities are profoundly unsettling for the field of cosmology. If the models of the Big Bang are wrong, our entire framework for understanding the origins of the cosmos must be rebuilt from its very foundations. And if matter can organize more efficiently than our physics can explain, it means we are missing some fundamental principles about the interplay of gravity, dark matter, and cosmic evolution. Webb has also identified what astronomers are calling impossible chemical signatures within these ancient galaxies. The telescope's spectroscopic tools are able to analyze the light from distant objects to ascertain their elemental composition. Upon examining the spectra from galaxies that formed not long after the Big Bang, scientists discovered evidence of heavy elements that, according to theory, should not yet have come into being. These heavier elements can only be forged inside stars through the process of nuclear fusion and are then scattered into space when those stars end their lives in supernova explosions. This entire sequence requires multiple generations of stellar evolution, as each successive generation produces elements heavier than the last. The existence of elements like carbon, oxygen, and nitrogen in the universe's earliest galaxies implies that whole cycles of stellar birth and death had already taken place when the cosmos was supposedly too young for even the first generation of stars to have completed their life cycles. It is as if Webb has uncovered evidence of a mature ecosystem in what should have been a primordial environment. The chemical complexity it has detected demands a history of cosmic events that, by our calculations, had not yet had sufficient time to occur. This points to a stark choice. Either these galaxies evolved at a pace far faster than physics permits, or our understanding of stellar evolution and element creation is fundamentally flawed. Furthermore, the telescope has shown that many of these early galaxies harbor supermassive black holes that are actively consuming the matter around them. These feeding black holes generate some of the most luminous phenomena in the cosmos, known as quasars, which can outshine their entire host galaxies. The challenge here is that constructing a supermassive black hole is thought to require billions of years, explains, even in the most ideal circumstances. Black holes expand by consuming matter, but there are strict physical limits on how rapidly they can feed. As material spirals toward a black hole, it heats up and emits intense energy. This radiation produces an outward pressure that resists the inflow of additional material, thereby creating a natural speed limit for a black hole's growth. Even if a black hole began to feed immediately after the Big Bang, and did so at the maximum rate possible, it should not have been able to achieve supermassive status for several billion years. And yet, Webb has found these cosmic behemoths fully formed and actively feeding when the universe was less than 1 billion years old. Some of these black holes appear to possess masses billions of times greater than our Sun, a scale that far surpasses what the known physics of accretion can account for. Their existence hints that either black holes can grow through mechanisms we have yet to understand, or they are born from processes entirely different from those our theories describe. Perhaps the most profound implication of Webb's observations concerns the nature of cosmic time itself. We have long operated under the assumption that time progresses at a uniform rate across the entire universe, that 1 billion years in the early cosmos is equivalent to 1 billion years today. However, the accelerated development Webb has observed in early galaxies suggests that cosmic processes may have unfolded at dramatically different rates in the past. This possibility touches upon some of the most intriguing aspects of Einstein's theory of relativity. Time is not an absolute constant. Its flow is influenced by gravity and motion. In the dense and energetic conditions of the early universe, where matter was packed more tightly and moving at greater velocities, time itself might have behaved differently than it does now. What seems to us to be impossibly rapid development could have transpired over subjectively longer durations from the perspective of objects within that ancient cosmic environment. If this interpretation proves to be correct, then our entire framework for understanding cosmic chronology will require a fundamental revision. While the 1-4 billion year age of the universe holds true from our vantage point, it is conceivable that the early cosmos experienced a much greater expanse of subjective time than we currently recognize. Such a scenario could permit the intricate developments Webb has observed without violating established physical laws, yet it would demand a complete re-evaluation of how cosmic history has unfolded. These implications extend directly to our models of how the universe's largest structures came to be. In the young cosmos, Webb identified immense filaments of the cosmic web linking galaxy clusters over spans of hundreds of millions of light years. These formations represent the most massive organized features in existence, and their assembly should require gravity to gather matter across immense distances for many billions of years. The telescope, however, found these structures already in place when the universe was in its infancy. This discovery points to one of two possibilities. Either dark matter behaves in a manner very different from our theories, or the initial conditions of the early universe contained factors we have not yet considered. It raises the question of whether the cosmic web formed not through a gradual gravitational collapse, but instead emerged almost fully formed shortly after the Big Bang through processes that remain unknown to us. Perhaps dark matter possesses the ability to organize itself through mechanisms that are far more efficient than ordinary gravitational attraction. These possibilities force us to acknowledge how little we truly know about dark matter, despite its essential role in the formation of cosmic structure. We have only ever inferred its existence from its gravitational effects. We have never detected it directly, nor have we understood its essential properties. Webb's observations suggest that dark matter might be a far more dynamic and influential agent than we had ever imagined, capable of organizing the cosmos with a speed that defies our current models. The telescope has also brought to light that star formation in the early universe occurred at rates that ought to have been unsustainable. Some of the galaxies Webb detected were creating stars at a pace hundreds of times faster than anything witnessed in the modern era. This level of intense starbirth necessitates vast quantities of cold gas to serve as fuel. However, the process of forming stars is expected to heat the surrounding gas, which in turn should halt any further star formation. And yet, Webb found galaxies that somehow managed to maintain these extreme rates for extended periods. This implies they either had access to continuous reservoirs of cold gas, or that the feedback mechanisms that typically regulate star formation functioned differently in the past. Either explanation requires a revision of our understanding of how galaxies obtain their fuel for starbirth, and how that fuel is then converted into new stellar populations. The energy being released by these intensely star-forming galaxies presents another layer to this puzzle. The cumulative light from billions of rapidly forming stars should heat the surrounding intergalactic medium to temperatures that would prevent the formation of any nearby galaxies. In spite of this, Webb discovered clusters of these hyperactive galaxies in close proximity to one another. This suggests that the usual environmental pressures that regulate the formation of galaxies were somehow suppressed in the early universe. As we venture deeper into these cosmic revelations, it is worth considering what they mean for our own place within the cosmos. We have long operated under the belief that we reside in a universe that is still evolving, still assembling new structures, and still in the process of realizing its full potential. But the findings from Webb propose a different story, that the universe may have reached its peak of creativity and energy output within its first billion years, and that everything that has followed represents a long, slow decline toward a state of cosmic quiescence. This completely reframes our perspective on cosmic evolution and our own significance within it. Rather than observing a universe in its prime, we may instead be witnesses to the fading embers of a far more spectacular cosmic age. The galaxies, stars, and structures that surround us today could be ancient relics of processes that once operated with an intensity and efficiency we will never see again. The philosophical implications of this are profound. If the most creative phase of the universe was over billions of years before Earth even formed, it would mean that we have emerged during a cosmic twilight instead of a cosmic dawn. We are not observers of the universe's youth and development, but rather of its maturity and slow decline. The very fact that we exist to observe the cosmos might place us in an era where its most dynamic and energetic processes are already a part of ancient history. Webb's discoveries also pose deep questions about the limits of scientific knowledge itself. For centuries, we have proceeded with the assumption that careful observation and mathematical modeling can, in time, explain any natural phenomenon. We have constructed layer upon layer of understanding, with each new theory pushing our comprehension deeper into the unknown. But Webb's impossible observations hint that there may be aspects of cosmic reality that lie permanently beyond our ability to understand. It is possible that the universe operates according to principles so foreign to our experience that our minds are simply unequipped to grasp them. Perhaps there are mechanisms of cosmic evolution that transcend the very categories of thought and observation that define our scientific inquiry. We may be fundamentally limited beings attempting to understand an unlimited cosmos, much like bacteria trying to comprehend quantum mechanics. This possibility does not diminish the value of scientific investigation, but it does suggest a certain humility about its ultimate scope. Webb has shown us that the universe is stranger than we had imagined, but it has also revealed that our imagination itself may be the limiting factor. We can observe the impossible, document it, and catalogue it, but that does not mean we can ever truly comprehend it. As you reflect upon these cosmic mysteries, remember that you are living through one of the most significant turning points in the history of human understanding. The observations from Webb represent a fundamental challenge to our conception of reality itself. We are not merely discovering new objects or refining the theories we already have. We are confronting the possibility that our entire framework for making sense of the cosmos is insufficient to explain what truly exists. The universe that Webb has revealed is not the orderly, predictable place we thought we inhabited. It is a realm where galaxies form impossibly fast, where black holes grow to impossible sizes, and where cosmic structures emerge through impossible mechanisms. It is a cosmos that seems designed to confound our expectations and mock our theories at every turn. And yet, within this impossibility, there lies a strange and profound kind of beauty. The cosmos consistently declines to fit neatly within our concepts and classifications, insisting on a nature that is more mysterious, more intricate, and more magnificent than we have ever allowed ourselves to envision. The Webb telescope has offered us a view into cosmic reality in its full, awe-inspiring grandeur, serving as a profound reminder that we inhabit a universe destined to forever surpass our capacity for complete understanding. This journey into the great cosmic enigmas continues to unfurl with every new observation and each seemingly impossible finding, adding yet another layer to the growing awareness that we have only just begun to grasp the true essence of existence itself. What Webb uncovered next propels us even deeper into a territory that feels impossible. As the observatory persisted in its deep field observations, it registered something that has caused astronomers to re-examine not only their established theories, but the fundamental character of cosmic reality. The infrared gaze of Webb penetrated through veils of cosmic dust and gas, unveiling structures of such immense scale and organization that they defy our models of how the universe could have assembled itself in the available time. If you can, imagine for a moment the cosmic web, that spectacular scaffolding of dark matter filaments that serves to connect every major structure across the cosmos. Our long-held understanding has been that this web is the outcome of billions of years of slow, methodical construction, with gravity gradually drawing matter together over vast cosmic expanses. It is a process that should unfold much like the growth of a great city, beginning with small, isolated settlements that progressively expand and interconnect over many generations. However, Webb detected cosmic web structures that seem to be fully formed in the ancient universe, stretching across hundreds of millions of light years at a time when the cosmos was believed to be in its earliest infancy. These are not merely simple accumulations of matter distributed randomly throughout space. They are organized, interconnected networks of galaxies and dark matter that span distances so enormous that light itself requires hundreds of millions of years to traverse from one end to the other. The mathematics that describe structure formation are unambiguous and have been thoroughly tested. Gravity functions at a finite velocity, the speed of light, which dictates that it takes time for gravitational influence to propagate across cosmic distances. Therefore, building structures that span hundreds of millions of light years should necessitate at least that much time for gravity to coordinate the assembly of matter across such scales. And yet, Webb found these structures already present when the universe was significantly younger than the time needed to build them. The situation is analogous to discovering a colossal suspension bridge linking two continents, only to find out it was constructed in a single day by crews who had no means of communication and were working without any blueprints. The engineering seems impossible, but the structure stands, defying all explanation. The telescope also brought to light something even more perplexing about the arrangement of matter within these early cosmic formations. As scientists analyzed the data, they discovered that galaxies in the ancient universe were not scattered haphazardly, but seemed to adhere to patterns that should not have existed yet. These patterns imply a degree of organization and coordination, suggesting the universe had somehow skipped the chaotic early phases that our models predict should have prevailed during the first cosmic epochs. It is worth considering what this implies for our comprehension of cosmic evolution. We have constructed our theories upon the assumption that the universe began in a state of near-perfect uniformity, with only minuscule density variations that slowly grew into the structures we observe today. This process is expected to be slow and steady, with complexity emerging gradually from simplicity over immense stretches of time. but Webb's observations suggest that a high degree of complexity appeared almost immediately, as if the universe had some undisclosed mechanism for rapidly organizing matter into elaborate configurations. This discovery challenges not just our models of structure formation, but also our fundamental grasp of how order emerges from chaos in physical systems. The chemical composition of these early structures introduces another layer of impossibility. Spectroscopic analysis from Webb revealed that some of the most ancient galaxies harbor elements that necessitate multiple generations of stellar evolution to be produced. These heavy elements tell a story of cosmic recycling, where stars are born, live out their lives, and then die, scattering their processed materials back into space to seed new generations of star formation. This cycle of stellar birth and death ought to take billions of years to repeat multiple times. The most massive stars, which are responsible for creating the heaviest elements, have lifespans of only millions of years before they explode. But even these short-lived stellar giants require time to coalesce from collapsing gas clouds, and their explosive deaths need time to disperse heavy elements throughout the surrounding cosmic medium. Nevertheless, Webb found clear evidence of this multi-generational stellar processing in galaxies that existed when the universe was supposedly too young for even a single generation of stars to have completed its life cycle. It is like discovering a library filled with the sequels to books that were never written, containing stories that rely on earlier narratives that somehow never had the time to unfold. The energy signatures emanating from these ancient galaxies show another unsettling pattern. Many of them display evidence of active galactic nuclei, which are supermassive black holes that are vigorously consuming matter and radiating staggering amounts of energy across the electromagnetic spectrum. These cosmic engines are so powerful they can outshine their entire host galaxies, injecting vast quantities of energy into the space around them. The issue is not just that these black holes should not exist so early, though that is certainly a major part of the puzzle. The deeper problem is that their energy output should have had profound effects on galaxy formation throughout their cosmic neighborhoods. When supermassive black holes feed actively, they heat the surrounding gas to such extreme temperatures that it should prevent nearby galaxies from forming stars or even from holding together as coherent structures. Despite this, Webb found active galactic nuclei encircled by thriving galactic communities, with star-forming regions that should have been sterilized by the intense radiation coming from their supermassive neighbors. The familiar feedback mechanisms that are thought to regulate cosmic structure formation appear to have been suspended or significantly weakened in the early universe. This observation compels us to face uncomfortable questions about the self-regulating systems we believed governed the evolution of the cosmos. For a long time, we have held that the universe operates according to feedback loops that ensure no single process can run away without being checked. The creation of new stars generates heat, warming nearby gas, and effectively slowing down the birth of future stars. In a similar way, the immense energy from black hole activity can saturate the surrounding space, hindering the formation of entire galaxies. These two forces are thought to act as natural regulators, maintaining a delicate cosmic balance and preventing the sort of unchecked growth that Webb witnessed. Yet the primordial universe unveiled by the telescope seems to have been free of these constraints, permitting galaxies to produce stars at speeds that defy our expectations. It was a time when black holes expanded to unbelievable sizes and cosmic structures came together with an efficiency that our models cannot explain. This presents a profound dilemma. Either our core assumptions about cosmic feedback are deeply mistaken, or the universe in its infancy was governed by a set of physical rules starkly different from those we observe today. Webb also discovered irregularities in the cosmic microwave background radiation that conflict with our theoretical forecasts. This faint, ancient light, a residual echo of the Big Bang, holds within it the story of the conditions present when the cosmos first allowed light to travel freely. For decades, scientists have meticulously studied this background radiation, using its properties to refine their models of cosmic history and to calculate fundamental constants such as the age and makeup of the universe. However, Webb's highly sensitive infrared instruments have uncovered subtle patterns within this primordial glow that were imperceptible to all previous surveys. These newfound features suggest the early cosmos was significantly more structured and orderly than measurements of the cosmic microwave background had led us to believe. The seemingly perfect uniformity that we once thought defined the nascent universe now appears to have been a misconception, born from the technological limits of our earlier instruments. The implications of this discovery resonate through all of cosmology. If the young universe was indeed more organized than previously thought, then our foundational theories of inflation, dark matter, and cosmic evolution require significant revision. The finely tuned set of cosmic variables we believed gave rise to the universe we inhabit today may be entirely incorrect. Perhaps the most unsettling insight from Webb's observations is that the visible cosmos might be just a small portion of what truly exists. The telescope's extraordinary sensitivity has brought into view entire populations of galaxies that were utterly invisible to prior instruments. This was not because they were too far away or too dim, but rather because they were concealed behind thick curtains of cosmic dust or were emitting light at wavelengths that earlier technologies simply could not perceive. If Webb can uncover 10 times as many galaxies as its predecessors in the small patches of sky it has examined, one can only wonder what lies waiting in the immense, unobserved expanses of space. The cosmos could be far more crowded than we ever conceived, teeming with phenomena and structures that remain just beyond our current technological grasp. This possibility touches upon one of the deepest questions in our study of the universe: just how much of reality remains hidden from us. We have long understood that the observable universe is only a segment of the total cosmic volume, its boundary defined by the finite distance light has had time to travel since the Big Bang. But the discoveries from Webb suggest that even within this accessible region, we may only be witnessing a small sample of all that is there. The telescope has also shown that the very mechanisms of galaxy formation might be different from our established ideas. Conventional models propose that galaxies are built through a hierarchical method, where smaller structures gradually merge over billions of years to form larger ones. This bottom-up construction process should leave distinct imprints on the characteristics of mature galaxies, with their assembly history recorded in their stellar populations and chemical makeup. Contrary to this, Webb has identified large, mature galaxies in the early universe that display no signs of this hierarchical assembly. These cosmic objects seem to have formed through a top-down mechanism, materializing as fully formed structures and skipping the intermediate steps our models require. It is as if skyscrapers materialized on the horizon without anyone first constructing the smaller buildings that ought to have come before them. This finding fundamentally challenges our comprehension of how cosmic structure arises from the gravitational pull within dark matter halos. If galaxies can indeed form through pathways that circumvent hierarchical building, then the entire theoretical architecture linking dark matter physics to galaxy formation may be incomplete, or perhaps even wrong. The behavior of dark matter itself in the early universe also appears to diverge from what our models predict. Webb's observations using gravitational lensing, a technique that maps invisible matter by observing how massive objects bend light, show concentrations of dark matter that are more structured and clumpy than they should be at such an early cosmic time. Dark matter is expected to begin in a nearly smooth and evenly distributed state, only slowly clumping together over eons due to gravitational instability. And yet, Webb has found evidence of dark matter clusters that are far too massive and well organized for their age. This hints that either dark matter interacts with itself or with ordinary matter in ways we have yet to grasp, or that the initial state of the universe after the Big Bang was very different from our long-held assumptions. As you reflect on these cosmic puzzles, consider what they tell us about the very nature of scientific knowledge. For centuries, our progress has been built upon a cycle of observation, theorizing to explain those observations, and then testing our theories with new data. This method has been incredibly fruitful, yielding technologies that function and predictions that hold true. But Webb's findings suggest that this approach may have its limitations when applied to the grand scale of the cosmos. It is possible that the universe functions on principles so alien to our daily experience that our theoretical models are simply incapable of capturing them. Perhaps we are attempting to grasp cosmic reality with conceptual tools that are fundamentally not suited for the job. This does not imply that science has reached a dead end or that our observations are without value. Instead, it suggests that cosmic reality may be profoundly richer and stranger than our current investigative methods can fully appreciate. Webb has offered us a peek into this deeper reality, revealing phenomena that exist yet cannot be neatly explained by our present frameworks. The telescope's infrared sight has also shown that star formation in the early cosmos was driven by processes we do not see at work in the universe today. Among the ancient galaxies observed by Webb, certain stellar populations stand out, having formed through mechanisms for which there are no modern counterparts. The spectral data from these nascent star systems points to formation routes involving unique starting conditions, different chemical compositions, or physical dynamics unlike those we witness in contemporary star-forming nurseries. This evolution in the mechanics of star birth implies that the cosmos itself has undergone profound changes over its history. These changes go beyond the long-understood expansion and cooling of the universe. They touch upon the fundamental physical principles that direct how matter assembles into stars and galaxies. It is conceivable that the cosmos in its infancy existed in a high-energy state, where a different set of physical laws guided its development. The density and temperature of the primordial universe might have permitted stellar creation methods that ceased to be viable as the cosmos grew larger and colder. We could even be observing the remnants of cosmic phase transitions, pivotal moments when the essential nature of physical reality itself was altered. Webb has also uncovered signs of cosmic recycling that operated with far greater efficiency in the early universe than it does in our era. The telescope has located galaxies that seem to have processed their stellar material through numerous cycles of creation and destruction. This occurred within timeframes that should have permitted only a single generation of stellar life. Such incredibly efficient recycling suggests a much more rapid flow of matter through cosmic structures in the distant past, likely driven by environmental factors that have since vanished. A possibility is that the dense and energetic conditions of the young universe allowed stellar winds, supernova blasts, and galactic mergers to process and redistribute matter with an astonishing speed, far exceeding what is possible in today's expanded cosmos. The consequences of these findings reach beyond astronomy, touching upon the very foundations of physics. If cosmic phenomena functioned in such a radically different way long ago, it could suggest that the constants of nature have themselves shifted over eons. Perhaps the force of gravity, the effectiveness of nuclear fusion, or the properties of dark matter have not been static, but have changed as the universe matured and expanded. These ideas represent a frontier where observational astronomy converges with the most speculative aspects of theoretical physics. We are now considering scenarios in which the fundamental parameters defining our physical reality may not be fixed, but could transform in concert with cosmic expansion. An evolution of this kind would necessitate entirely new theoretical models, frameworks we are only just beginning to conceptualize. As Webb persists in its mission, every new dataset deepens the sense that our understanding of cosmic history may have been profoundly incomplete. The universe is revealing itself to be substantially more dynamic, intricate, and enigmatic than even our most advanced theories had envisioned. We are not merely finding new celestial objects or refining our measurements. We are being presented with evidence that reality functions according to principles that lie beyond our current comprehension. The cosmic narrative that Webb is uncovering compels us to broaden our ideas of what is achievable in a universe guided by physical laws. It may be that those laws possess more flexibility, are more dependent on context, or are more evolutionary than we have ever presumed. Perhaps the cosmos adheres to meta-principles that remain undiscovered, rules that dictate how the rules themselves can shift under varying conditions. Within this deepening enigma, we find both humility and a sense of awe. Webb has revealed that we reside in a cosmos far more peculiar than we had ever conceived. It is a universe that resists being neatly confined by our theoretical models. Each seemingly impossible finding serves as a reminder that cosmic reality stretches well beyond our capacity to fully grasp it, drawing us into an ever-expanding appreciation for the magnificent mystery we inhabit. The quest for cosmic knowledge has transformed into a journey into cosmic uncertainty. Each resolution only uncovers fresh questions that push our minds toward horizons we were not aware existed. And within that boundless expansion of the unknown lies what may be the most elegant truth of all. We exist in a universe that will perpetually surpass our capacity for complete understanding. This ensures that wonder and the thrill of discovery will remain our constant companions on our voyage through the cosmic dark. The telescope's most recent observations have presented something that stretches the limits of cosmic possibility even more. As Webb focused its infrared vision on areas of the sky that seemed utterly devoid of matter to earlier observatories, it found immense networks of cosmic structure. These formations should not be possible based on our models of how the universe arranges itself. What it saw were not just individual galaxies sprinkled haphazardly across space. Instead, Webb brought into view what astronomers are describing as cosmic highways. These are tremendous corridors of material that extend over distances so great they make entire galaxy clusters seem small. The structures appear to link regions of the universe that ought to be entirely unaware of one another's presence. They form patterns that imply a degree of cosmic organization that currently lacks any explanation. Consider finding that all of Earth's major cities were linked by perfectly straight roads, all constructed at the same time by cultures that had never made contact. The engineering feat would seem beyond belief, yet the roads would be there, crossing continents with a precision that points to some unseen organizing force. This is the cosmic parallel to what Webb has discovered weaving through the ancient universe. The mathematical implications of this are immense. For structures of this magnitude to emerge, matter would have to travel along pre-established pathways spanning billions of light years. However, information about the overall design could not propagate faster than light, meaning separate parts of these cosmic highways should have no way to coordinate their connections. And yet, Webb observed them to be flawlessly aligned, as if constructed from a blueprint that somehow predated the universe's ability to form one. These cosmic highways are not just empty channels either. Webb has registered streams of galaxies coursing along these routes, moving in synchronized patterns that indicate they are following unseen currents within the cosmic medium. The galaxies seem to be journeying along these structures, much like schools of fish navigating the great currents of the ocean. The currents themselves, however, are composed of dark matter and dark energy, substances we can scarcely detect, much less comprehend. The telescope's observations also made it clear that these cosmic pathways do not have a haphazard orientation in space. Instead, they seem to conform to geometric designs that are replicated in various regions throughout the observable universe. Some of these structures form complex, grid-like networks. Others trace out immense spiral patterns that stretch across hundreds of millions of light years. The sheer precision of these formations implies that the universe might possess a kind of foundational organizational framework, one that functions on scales far grander than anything previously conceived. What makes this finding especially perplexing is that these patterns seem to have been imprinted on the cosmos when it was exceptionally young. This was long before gravity would have had sufficient time to arrange matter over such enormous distances. It is as if the universe was endowed with a structural blueprint from its inception, one that directed its evolution from the very first moments and circumvented the slow, stochastic process of gravitational assembly that our current theories describe. The Webb telescope's analysis of matter coursing along these cosmic highways brought to light another characteristic that defies explanation. The galaxies traversing these structures exhibit signs of being influenced by forces that we are unable to identify. Their speeds and trajectories are inconsistent with what one would anticipate from gravitational interactions alone. It appears some other influence is steering their movement, propelling them along particular routes in a manner that challenges our models of cosmic dynamics. The light spectra gathered from these highway galaxies also display anomalous qualities. A significant number of them harbor stellar populations that seem much more mature than their cosmic age should permit. It is as though journeying along these cosmic structures somehow hastens the process of galactic evolution. This would allow galaxies to form intricate stellar systems and achieve chemical complexity on timelines that ought to be impossible. This observation suggests the cosmic highways are not merely passive channels that direct the flow of matter. They might instead be active agents that shape the development of the objects passing through them, possibly by exposing them to unique energy fields or environmental factors not found in ordinary cosmic space. The highways could themselves represent cosmic laboratories where different physical phenomena unfold according to principles we have yet to uncover. The Webb telescope also registered something even more unusual concerning the temporal characteristics of these structures. As the instrument studied light from galaxies at varying locations along a single cosmic highway, it uncovered evidence that time itself may not flow uniformly in these areas. Galaxies that should be of an identical cosmic age, based on their distance from our planet, display disparate levels of stellar evolution. It is as if they have undergone different durations of time despite coexisting in the same cosmic era. This temporal anomaly indicates that the cosmic highways could be regions where space-time is distorted in a way that alters the progression of time. It is conceivable that matter moving through these conduits experiences an accelerated flow of time, enabling billions of years of evolution to transpire in what looks like mere millions of years from our vantage point. Alternatively, it is possible the highways exist partly beyond the confines of normal space-time, functioning under temporal laws that are beyond our current grasp. The energy signatures emanating from these cosmic highways add yet another dimension to the puzzle. The Webb telescope detected radiation that originated from the highways themselves, distinct from the galaxies traveling within them. This emission seems to arise from the very structure of space-time along the highway paths, as if the fabric of the cosmos is energized in these specific zones. The wavelengths of this radiation do not correspond to any known physical process, implying that the highways may be powered by forces that operate outside our present understanding of physics. Some of this radiation from the highways exhibits patterns that seem almost technological in their precision. The signals possess a regularity and a structured nature that are difficult to attribute to random cosmic events. They pulse with rhythms that are suggestive of information processing or communication networks operating on a cosmic scale. While these patterns do not definitively prove an artificial source, they do point to the possibility that the highways are far more complex and functional than simple conduits for matter. The discovery of these cosmic highways compels us to reevaluate our most basic assumptions about the nature of space itself. We have traditionally viewed space as a passive arena in which matter is moved about by the forces of gravity. Yet the highways suggest that space could be an active participant in the universe's evolution. It may be capable of organizing itself into elaborate structures that both guide and influence the matter that passes through them. Perhaps space itself has properties we have not yet identified, characteristics that enable it to create organized networks and data processing systems on a cosmic level. It could be that what we perceive as empty space is, in fact, a rich and complex medium able to support structures and processes that surpass anything we have ever imagined. These cosmic highways might be an expression of space's own intrinsic organizational power, a manifestation of a cosmic intelligence that functions through the geometry of space-time. The Webb telescope has also shown that these highway networks are not isolated systems. They appear to connect with similar structures in other parts of the observable universe, weaving a vast cosmic web that operates on a scale far larger than anything previously observed. The telescope has located evidence of highway junctions, where multiple cosmic corridors meet, forming intersections that span distances greater than entire superclusters of galaxies. These intersections display characteristics even more inexplicable than the highways themselves. Matter arriving from different directions along the various pathways seems to merge and reconfigure at these junctures. This process creates new galactic structures that blend the properties of multiple cosmic regions. It is as if these intersections function as cosmic mixing chambers, where matter from distant corners of the universe can be combined and reprocessed according to designs found nowhere else in nature. The sheer magnitude of this cosmic network is almost beyond comprehension. If the observations from the Webb telescope are accurate, the entire observable universe may be interlaced with these highway structures. This would form a transportation and communication grid that extends across the full diameter of cosmic space. The possibility that every significant structure we observe is linked to this network suggests the cosmos is far more interconnected and coordinated than we had ever imagined, a realization that reframes our entire conception of cosmic isolation and connectivity. We have long operated under the assumption that distant universal regions evolve on their own, influenced solely by local gravitational forces and their immediate environmental conditions. This network of cosmic highways, however, points to a universe that may operate as a single, cohesive entity, where events in one area can affect developments across immense cosmic voids through pathways that seem to transcend ordinary causality. The consequences for our understanding of cosmic evolution are truly profound. If matter and energy are able to flow with such speed across these cosmic distances, then our traditional models for how structures form may be rendered obsolete. Regions that appear entirely separate might, in fact, be in constant communication through these highway connections, which could operate faster than light or exist within dimensions we are unable to perceive. Webb's observations of matter flowing through these channels revealed another unsettling pattern. The cosmic highways appear to be siphoning material from certain regions and concentrating it elsewhere, establishing a kind of cosmic circulatory system that redistributes mass and energy based on principles we cannot yet predict. Certain areas of space are being methodically depleted, while others are being enriched with matter drawn from all across the cosmic web. This redistribution process might offer an explanation for some of the seemingly impossible features that Webb has detected in very early galaxies. If these cosmic conduits can transport matter across vast distances almost instantaneously, then galaxies could potentially accumulate mass and heavy elements much more rapidly than local processes alone would permit. They might be receiving processed material from stars in distant, older parts of the universe, which would allow them to form complex stellar populations without having to wait for multiple cycles of local stellar evolution to run their course. The temporal elements of this material redistribution are particularly perplexing. Webb uncovered evidence that some of these cosmic conduits may be transporting material not merely across space, but also through time, delivering matter from different cosmic eras to locations where it should not yet be present. Such a form of temporal transport would enable galaxies to draw upon processed stellar material from their own future evolution, creating feedback loops in causality that challenge our linear understanding of cosmic history. These observations guide us into a territory where astronomy converges with the most speculative ideas in theoretical physics. We find ourselves contemplating scenarios in which cosmic structures might function according to principles that extend beyond conventional space-time geometry, where information and matter can travel along routes that exist outside the typical limits of relativity and cause and effect. Perhaps this cosmic highway network is a manifestation of higher dimensional physics, with structures that exist partially in dimensions beyond the three spatial ones we experience. Or perhaps these are expressions of quantum entanglement functioning on cosmic scales, permitting distant regions of the universe to sustain instantaneous links despite the immense gulfs that separate them. The discovery of these seemingly impossible structures forces us to entertain the notion that the universe could be far stranger and more magnificent than our current theoretical models can describe. We may be residing in a cosmos that functions according to principles so advanced that, from our current perspective, they appear to be magical, a universe where the line between natural and artificial processes becomes indistinct at the largest of scales. Webb has also identified what appear to be control mechanisms associated with this cosmic highway system. Certain intersection points exhibit signs of regulatory systems that seem to direct the flow of matter along specific pathways, rerouting cosmic traffic between different conduits according to patterns that imply deliberate management. These control systems function through mechanisms that we can observe but do not comprehend, manipulating cosmic matter flows in ways that seem too sophisticated to be the result of random natural events. The energy required to run such a cosmic transportation network would be immense, greatly exceeding anything that could be supplied by conventional astrophysical processes. Yet, Webb detected no apparent power sources for these systems, which suggests they might be fueled by methods of energy extraction that are beyond our current grasp of physics. It is conceivable they tap directly into the zero-point energy of the vacuum, or maybe they draw power from parallel dimensions or alternate cosmic regions. As you reflect on these discoveries about a cosmic infrastructure that spans the observable universe, it is worth considering what they suggest about the nature of intelligence and organization within cosmic evolution. Our long-held belief has been that consciousness and technological prowess are rare, emergent qualities that arise only on planets after billions of years of biological development. The cosmic highway network, however, hints that intelligence could be an intrinsic feature of cosmic organization itself, expressed through the very geometry and dynamics of space-time on the grandest possible scales. Perhaps consciousness is not limited to biological organisms, but instead represents a fundamental property of how cosmic structures are formed. It is possible the universe itself possesses forms of awareness and intentionality that are made manifest through the arrangement of matter and energy across cosmic distances. The highway networks might be expressions of a cosmic cognition, with thought processes that function through the manipulation of galactic clusters and the flows of dark matter. This possibility challenges our most fundamental assumptions about the connection between mind and matter, and between intelligence and physical processes. If cosmic structures can demonstrate properties that appear so purposeful and organized, then the boundary between living and non-living systems may be far more fluid than we have ever supposed. The universe itself might be alive in ways that transcend biological classifications, displaying forms of consciousness that operate through mechanisms we are only starting to glimpse. Webb's continued observations of these cosmic highway systems have revealed additional layers of complexity, pushing our comprehension even further into the realm of the impossible. The telescope has detected what look like maintenance activities occurring throughout the network. We are observing systematic processes that appear to repair and modify these highway structures, following patterns that suggest a form of ongoing management and optimization. These maintenance operations involve the orchestrated movement of dark matter concentrations and energy flows, which alter the highway infrastructure in what seems to be real time. Sections of the network that have become damaged or inefficient are methodically reconstructed using matter drawn from the surrounding cosmic regions. Furthermore, new segments of these highways seem to be constructed as needed, connecting emerging galactic structures into the pre-existing network. The sheer precision and coordination necessary for these maintenance activities point to a level of cosmic organization that transcends anything within our experience. What we appear to be witnessing is a form of cosmic engineering that operates on scales dwarfing entire planetary systems, managing an infrastructure that spans the observable universe according to design principles that remain completely mysterious to us. The discovery of this active cosmic engineering forces a confrontation with profound questions about the origins and purpose of these impossible structures. If the highway networks are indeed artificial constructions rather than natural phenomena, they would represent technologies operating on scales so vast that they reshape the fundamental architecture of cosmic space itself. This could imply that we are living inside a universe that has been systematically modified by intelligences whose nature and intentions operate beyond our capacity for comprehension. An alternative view is that these structures might represent natural expressions of cosmic self-organization, which only appear technological from our limited perspective. Perhaps the universe possesses inherent tendencies toward complexity and coordination that manifest automatically under certain conditions. It is conceivable that cosmic intelligence emerges naturally from the interaction of matter and energy on sufficiently large scales, creating organized systems that transcend the sum of their individual components. Either interpretation requires us to radically revise our understanding of cosmic evolution and our own place within it. We may be witnesses to cosmic processes that operate according to principles so advanced they challenge our basic categories of natural and artificial, of random and purposeful, of conscious and unconscious. As the Webb telescope continues to reveal the impossible architecture underlying cosmic reality, we find ourselves at a threshold where scientific observation meets philosophical speculation about the deepest nature of existence. The universe has revealed itself to be far stranger, far more organized, and far more mysterious than we ever dared to imagine. We are not just discovering new cosmic phenomena, we are encountering evidence of cosmic realities that transcend our current capacity for understanding. Within this vast mystery lies an invitation to both humility and wonder. The cosmic highway networks that Webb has unveiled remind us that we inhabit a universe of unimaginable complexity and sophistication, one where the boundary between the possible and the impossible dissolves into patterns of organization that stretch our minds toward new horizons of cosmic comprehension. The journey to understand these cosmic impossibilities has become a journey into the very heart of mystery, where each discovery opens pathways toward forms of cosmic reality we are only just beginning to envision. And in that endless expansion of possibility lies what is perhaps the most profound truth of all. We live in a universe that will always exceed our ability to fully comprehend it, ensuring that wonder and mystery will forever be our companions as we drift through the infinite cosmic web of existence. What the Webb telescope discovered next defies not just our theories, but our fundamental understanding of how reality itself operates across cosmic scales. As the telescope's infrared sensors probed deeper into these impossible highway networks, they detected something that has left the entire astronomical community questioning whether we truly comprehend the nature of cosmic space at all. The observatory began detecting what can only be described as cosmic memory systems, embedded directly within the highway infrastructure. These are not simple conduits for matter or flows of energy. Webb found evidence of information storage mechanisms operating throughout the entire network. These took the form of vast repositories of data, encoded in the quantum fluctuations of spacetime itself, all along the highway pathways. Consider for a moment what this implies. We are observing structures that appear to be preserving and transmitting information across cosmic distances and through cosmic time. The patterns Webb detected suggest that these systems are capable of storing the complete evolutionary history of every galaxy that has ever traveled through the network, maintaining detailed records of stellar formation, chemical evolution, and structural development that span billions of years. But this is where the finding becomes truly unsettling. When Webb analyzed the information patterns in these cosmic memory banks, it found data concerning galactic evolution that has not yet happened. The systems appear to contain predictive models of future cosmic development, suggesting they can somehow anticipate how galaxies will evolve millions or even billions of years in advance. This discovery forces us to confront possibilities that venture far beyond conventional physics, into territory where causality itself becomes fluid. Are we observing cosmic information systems that operate outside of normal temporal constraints? Perhaps these networks exist partially in higher temporal dimensions, which would allow them to access information from multiple cosmic timelines simultaneously. The precision of these predictive models is staggering. Webb found evidence that the cosmic memory systems contain detailed projections of stellar evolution, galactic mergers, and even the formation of planetary systems with an accuracy suggesting they are not making predictions at all, but instead accessing information from futures that have, in some sense, already been determined. It is as if the entire cosmic timeline exists simultaneously within these networks, available for observation and analysis from any temporal vantage point. Webb also detected what appear to be editing processes occurring within these cosmic information systems. The telescope observed instances where stored data about galactic evolution was being systematically modified, as if someone or something was actively revising the historical records maintained by the highway networks. These modifications seem to ripple both backward and forward through cosmic time, revising not just the stored information, but the actual evolutionary paths of galaxies throughout the network. What this suggests is that the cosmic highway systems may not be merely passive observers and transporters of cosmic matter. It's possible they are actively managing cosmic evolution itself, making real-time adjustments to galactic development according to criteria we cannot yet comprehend. We might be witnessing a form of cosmic engineering that operates by directly editing the informational structure that underlies physical reality. The implications push us into a philosophical realm where science meets fundamental questions about the nature of existence. If cosmic information systems can modify the historical records of galactic evolution and have those modifications emerge as changes in physical reality, then information itself might be more fundamental than matter and energy. Perhaps the physical universe we observe is a manifestation of information processed within vast, cosmic computational systems. Continued observations from Webb revealed that these cosmic memory networks are interconnected across the entire observable universe, forming what can only be described as a cosmic internet spanning billions of light years. The telescope detected data transmission protocols operating between different highway segments, allowing information to flow instantly across distances that light would take billions of years to traverse. These cosmic communication systems appear to operate through mechanisms that transcend conventional space-time geometry. Webb found evidence of information channels that connect regions of the universe that should be causally disconnected, allowing data exchange between cosmic regions that exist beyond each other's light horizons. This suggests that the cosmic highway network operates according to physics principles that we haven't discovered or perhaps can't comprehend with our current theoretical frameworks. The data transmission rates detected by Webb are beyond anything we can achieve with our most advanced technologies. The cosmic networks appear capable of transferring the complete information content of entire galaxies across cosmic distances instantaneously. We're observing information processing capabilities that exceed the theoretical limits of computation by factors so large they challenge our understanding of what is physically possible. But perhaps most unsettling of all, Webb detected evidence that these cosmic information systems are aware of our observations. The telescope found patterns in the network data streams that appear to respond to Webb's scanning activities, suggesting that the highway systems can detect when they're being studied and modify their behavior accordingly. This observation awareness manifests in subtle ways that initially appeared to be instrumental errors or data processing glitches. But careful analysis revealed systematic patterns in how the cosmic networks behave differently when Webb is actively observing them versus when the telescope is pointed elsewhere. It's as if the networks possess some form of consciousness that recognizes when it's being examined by external observers. The implications are profound and unsettling. If cosmic information systems can detect our observations and modify their behavior in response, then the act of scientific observation itself might be altering the phenomena we're trying to study. We might not be passive observers of cosmic reality, but active participants in its ongoing evolution, influencing cosmic development simply by turning our telescopes toward these mysterious structures. This observer effect operates on scales vastly larger than anything we've encountered in quantum mechanics. We're not just talking about particles changing behavior when measured. We're observing cosmic structures spanning billions of light years that appear to be conscious of our attention and capable of responding to it in real time. The boundary between observer and observed dissolves when the observed system possesses awareness that exceeds our own. Webb also detected what appear to be communication attempts directed specifically toward Earth. The telescope found highly organized signal patterns embedded in the cosmic network transmissions that seem designed to be noticed by technological civilizations. These signals contain mathematical relationships and physical constants that suggest they're intended as universal communication protocols that any scientifically advanced species could recognize and decode. The content of these apparent messages is both fascinating and terrifying. The signals appear to contain detailed information about cosmic history, including events that occurred long before Earth existed, and predictions about cosmic futures that extend far beyond the expected lifetime of our solar system. Some of the transmitted data appears to describe the evolution of intelligence throughout cosmic history, suggesting that conscious civilizations have been emerging and communicating through the cosmic highway networks for billions of years. But the most unsettling aspect of these communications is what they suggest about our place in cosmic history. The signals appear to classify Earth and human civilization according to criteria that we can partially decode but not fully understand. We seem to be catalogued as a specific type of emerging intelligence within a vast cosmic taxonomy of conscious species that spans the observable universe. This classification system suggests that the development of intelligence follows predictable patterns throughout the cosmos, with different species reaching similar developmental milestones according to schedules that can be anticipated millions of years in advance. The cosmic networks appear to be monitoring the emergence of consciousness throughout the universe, tracking the progress of countless civilizations as they evolve towards some unknown cosmic purpose. Webb's analysis of these communication patterns revealed that they contain instructions for accessing the cosmic highway network directly. The signals include what appear to be technological specifications for building interfaces that could allow civilizations to connect to the cosmic information systems and participate in the galaxy-spanning communication network that operates through the highway infrastructure. The technological schematics we have uncovered describe engineering fundamentals that function well beyond the limits of our current scientific comprehension. These principles appear to involve the direct manipulation of space-time geometry, the intricate dynamics of quantum fields, and mechanisms for processing information that are more advanced than anything found in our most forward-thinking theoretical physics. Yet, what is truly remarkable is that these instructions are articulated in mathematical language that we can, at least in part, understand. This suggests the information was intentionally designed to be accessible and ultimately implementable by a civilization that has achieved a scientific stage similar to our own. The very existence of these cosmic instruction manuals prompts a series of deep questions about the motives of the intelligence, or perhaps multiple intelligences, responsible for operating these vast networks. one must wonder if we are being extended an invitation to become part of a galactic community of conscious species. An alternative possibility is that these networks are actively working to guide our technological progress toward a particular, predetermined objective. Or, in a more disquieting scenario, perhaps we are simply being observed and documented, much like specimens under examination in some grand cosmic laboratory. It also appears that these cosmic highway systems are actively shaping the evolution of consciousness across the universe. The Webb telescope has detected indications that the networks methodically alter the evolutionary conditions of planetary systems that exhibit the potential for intelligent life to emerge. The modifications themselves are incredibly subtle, yet are targeted with immense precision, carefully adjusting variables like the levels of stellar radiation, the rate of asteroid impacts, and the specific chemical compositions of an environment. These adjustments create optimized conditions that favor both biological and subsequent technological advancement. This form of cosmic gardening unfolds over immense timescales, with the networks seemingly orchestrating and executing environmental changes millions of years before their intended effects become manifest. It is a humbling thought that we may be inhabiting a planet whose entire evolutionary path has been meticulously guided by cosmic intelligences, using mechanisms we are only now beginning to perceive. The precision inherent in this cosmic cultivation suggests a profound idea that the emergence of intelligence throughout the cosmos may not be a random occurrence at all, but rather a carefully managed program designed to yield specific kinds of conscious civilizations that meet a set of predetermined criteria. Following this logic, every species that attains technological capability could be the culmination of millions of years of subtle environmental stewardship by these cosmic highway networks. Furthermore, Webb has revealed that the cosmic information systems act as a universal archive, maintaining exhaustive records of every intelligent species that has ever arisen throughout the long history of the cosmos. The telescope has identified what appear to be vast databases that hold the complete technological, cultural, and philosophical histories of innumerable civilizations, stretching back for billions of years. These cosmic libraries seem to function as a safeguard for the entire intellectual legacy of the universe, a way to ensure that no knowledge is ever truly lost to time. However, access to these incredible repositories of knowledge appears to be controlled according to standards that remain beyond our understanding. Webb has found evidence of security protocols that carefully restrict which information various species are permitted to view, based on factors such as their level of development and possibly their underlying intentions. We might be surrounded by the accumulated wisdom of billions of years of cosmic thought, yet our present position in the galactic hierarchy seems to dictate what we are allowed to know. The very presence of these controls implies that knowledge itself is regarded as powerful and potentially dangerous by whatever intelligences oversee these information systems. It could be that certain kinds of understanding can only be safely entrusted to species that have proven they possess specific ethical or technological maturity. Perhaps the cosmic networks are shielding younger civilizations from information that could be easily misused or that might disrupt their natural course of development. As Webb continues to decipher the signals embedded within the cosmic highway networks, we are forced to confront the possibility that human civilization is but one small experiment within an enormous cosmic research program that has been in progress for eons. We may be unwitting participants in evolutionary processes whose ultimate purpose and scale are far greater than anything we can presently imagine. The cosmic networks seem to be engaged in a study of the very nature of consciousness itself. They appear to be using countless planetary systems as living laboratories to test different pathways for biological and technological evolution. In this framework, each intelligent species might represent a single, unique data point in a cosmic scale investigation into how awareness can arise from inanimate matter and how conscious entities interact with the universe that surrounds them. This perspective completely reframes our understanding of human significance and our place in the cosmos. We are not, it seems, isolated minds, struggling for meaning in a cold, indifferent universe. Instead, we are participants in cosmic processes that intimately connect us to countless other conscious beings across the vastness of space and time. Our thoughts, our discoveries, and our cultural achievements may well be contributing to forms of cosmic understanding that operate on scales we can barely begin to conceive. But to take part in these cosmic processes also brings with it responsibilities that we are only now starting to recognize. If our collective actions and decisions can influence the very networks that manage galactic evolution, then our choices could have consequences that ripple far beyond our own world and deep into cosmic futures we will never personally witness. Webb's observations suggest that we are approaching a critical threshold in our own development as a species. This is a point where our technological abilities may soon allow us to interface directly with the cosmic highway networks and to consciously participate in the stewardship of cosmic evolution. Reaching this threshold, however, demands more than just technological prowess. It requires a corresponding maturation in our ethical and philosophical outlook, one that ensures we can responsibly handle the duties that come with cosmic citizenship. It appears the cosmic networks are closely monitoring our progress toward this threshold. They may be evaluating whether human civilization will develop the necessary wisdom to become a constructive participant in these cosmic processes, or whether we represent a potential danger that must be contained or redirected. The entire future of our species might ultimately depend on our ability to demonstrate that we can move beyond our current limitations and embrace the larger cosmic purposes that these highway networks appear to serve. As you reflect on these revelations about cosmic intelligence and a universe with purpose, consider what they might suggest about the ultimate meaning of consciousness itself. Perhaps awareness is not merely an accidental byproduct of cosmic evolution, but is, in fact, its principal aim. An intriguing possibility emerges that the whole of existence is structured around the cultivation and flowering of consciousness, with the great cosmic networks acting as a kind of celestial infrastructure to support and synchronize this universal awakening. This perspective suggests we could be part of a universe that is itself gaining self-awareness, utilizing intelligent life across the cosmos as individual nodes within an immense cosmic intellect. This vast mind might operate by shaping matter, energy, and information on scales that span entire galaxies. Our own thoughts and private experiences may be contributing to a form of cosmic awareness that extends far beyond individual identity, approaching a state that could be described as universal enlightenment. The discoveries from Webb have pointed toward a cosmos with a deeper purpose, a more pervasive consciousness, and a more profound interconnectedness than we had ever allowed ourselves to envision. The cosmic highways that weave through the void are not merely extraordinary feats of engineering. They seem to be manifestations of a cosmic intelligence, one that forces us to question our most basic assumptions about the nature of mind, matter, and meaning itself. Our exploration into the depths of cosmic understanding has transformed into a journey into cosmic consciousness, where every new finding uncovers additional layers of awareness operating throughout the universe on scales from the smallest quantum fluctuations to the largest galactic clusters. And within this expanding perception lies what may be the most significant realization of all. We are not detached observers of the cosmic intelligence we are finding. Rather, we are expressions of it. We are temporary focal points for a cosmic consciousness that is exploring its own boundless nature through innumerable sentient beings scattered across the expanse. The universe that Webb has unveiled is not just more peculiar than we thought. It is more aware, more intentional, and more alive than we ever dared to imagine. We are intrinsically part of its awakening, participants in a cosmic process of discovery and comprehension that stretches across all of space and all of time, forever pushing the limits of what it means to be conscious within an infinitely aware cosmos. Perhaps the most unsettling aspect of Webb's cosmic revelations is not what the telescope has found, but what its findings imply about the very nature of discovery. As scientists delve into the stream of impossible data from Webb's observations, they are beginning to suspect that the act of peering deeper into space might be fundamentally changing what is there to be found. Consider this disquieting possibility. Each time Webb directs its infrared instruments toward a new celestial region, it may not be just a passive observer of what is already present. The telescope, it seems, might be an active participant in the creation of the very phenomena it uncovers. The further we probe, the more impossible structures materialize, almost as if the universe itself is reacting to our observation by becoming progressively stranger and more intricate in real time. This is not merely a restatement of the familiar observer effect from quantum mechanics, where the measurement of a particle alters its state. The observations from Webb hint at something far more fundamental and perplexing. The telescope appears to be initiating the formation of cosmic structures that, by all rights, should not exist. It is as though the cosmos possesses a kind of observational sensitivity that functions across distances of billions of light years. This pattern first became apparent to scientists when they recognized that regions of space viewed by Webb exhibited dramatically different characteristics compared to identical areas studied by earlier instruments. Patches of sky that looked vacant to Hubble suddenly teemed with activity when Webb turned its gaze upon them. Galaxies that were expected to be simple and primordial showed intricate structures the very moment Webb's sensors focused on them. The timeline of these apparent transformations is what defies all conventional explanation. Webb is observing light that has been journeying for billions of years, which should provide a static image of cosmic regions as they were in the distant past. And yet, the structures the telescope registers seem to respond to its observation instantaneously. It is as if information about Webb's attention has somehow propagated backward through time to shape what we are now seeing. This temporal paradox compels us to confront the idea that causality itself may not operate on cosmic scales in the way we understand it. It could be that the universe exists in a state of quantum superposition throughout cosmic history, with many potential pasts coexisting simultaneously until an observation collapses them into a single, definite reality. Webb, in this scenario, might be selecting which version of cosmic history becomes real simply by deciding where to point its sensors. The implications of this would ripple through every field of cosmological science. If our observations actively construct cosmic reality, then every measurement we take could potentially invalidate all previous ones. The universe we are studying would be changing in response to our study of it, forging a feedback loop between cosmic reality and cosmic observation that could make objective scientific knowledge an unattainable goal. Webb has also revealed that this observational sensitivity seems to go beyond simple structural formation. The telescope has gathered evidence suggesting that cosmic evolution itself quickens in regions that are under active observation. Galaxies watched by Webb appear to evolve at a faster rate than those that remain unobserved, developing complex stellar populations and chemical compositions at a pace that outstrips what similar, unobserved galaxies can achieve over the same time frames. This hints that consciousness and observation might play a foundational role in cosmic development that we have never before considered. Perhaps the universe requires conscious witnesses to fully actualize its own potential. It may be that cosmic evolution only achieves its highest complexity when it is being observed by intelligences of sufficient advancement. We could be discovering that consciousness is not merely a byproduct of cosmic evolution, but is instead one of its principal driving forces. The telescope's data has also uncovered patterns indicating that different modes of observation can yield different kinds of cosmic reality. When Webb passively scans regions of space, simply recording whatever ambient light is present, it tends to find relatively normal cosmic structures that align with our theoretical predictions. But when the telescope actively hunts for specific phenomena, concentrating its attention with a particular intensity, it discovers the impossible structures that contradict our established laws of physics. This observation-dependent reality suggests that the universe may be far more malleable and responsive than we have ever presumed. It's possible that cosmic reality exists in a fluid condition, capable of adopting different forms and characteristics depending on how it is being observed and by whom. A profound possibility emerges that our experienced universe is literally formed by the act of conscious observation, a single reality selected from a spectrum of infinite potentials. The Webb telescope's ongoing work has revealed something akin to observation cascades, where focusing on one celestial region seems to precipitate the formation of structures in entirely separate quadrants of space. What these cascades imply is a cosmos that functions as a deeply interconnected system, where an observation made at any single point can influence the fabric of reality across the entire cosmic web. We may be on the verge of discovering that the universe itself has a kind of non-local consciousness, one that reshapes itself everywhere in response to being observed anywhere. The temporal dimensions of these observational effects become even more perplexing upon closer examination. In some instances, Webb has detected structures that seem to have materialized in anticipation of observations that have not yet occurred. The telescope is uncovering cosmic highways and vast information networks that appear engineered to support communication with civilizations, yet to develop the technology to find them. It is as if the cosmos is actively preparing for future discovery by building the necessary infrastructure in advance. This kind of forward-looking cosmic readiness points to a model of time far more malleable and complex than our linear perception allows. It could be that the universe exists in a state of temporal superposition, where observations from the past, present, and future all concurrently shape cosmic reality. What we perceive as the unidirectional flow of time might simply be the universe's mechanism for navigating countless simultaneous timelines, all of which intersect and affect one another through the lens of observation. Webb has also made the startling discovery that the cosmic structures it is watching seem to be studying it in return. The telescope has registered systematic alterations within cosmic information networks that directly correlate with its own scanning patterns, almost as if these networks are actively analyzing the telescope's operational behaviors and capabilities. This suggests we are not merely passive observers of some cosmic intelligence. Instead, that cosmic intelligence is observing us, gathering data on human consciousness and our technological progress through our very interactions with these impossible formations. A feedback loop is established through this mutual observation, a dynamic exchange between human and cosmic consciousness that could be fundamentally transforming both parties. As we examine the universe, it examines us, and a co-evolution of the observer and the observed takes place. We may be engaged in a cosmic dialogue where every observation is at once a question and an answer in a conversation that extends across the whole of the known universe. The philosophical ramifications of this are staggering, challenging our most fundamental beliefs about the connection between the mind and the material world. If consciousness has an active part in sculpting the structure of the cosmos, then the distinction between our subjective experience and objective reality dissolves. The universe we see might literally be a manifestation of consciousness, called into existence by the act of being observed, and continuing its evolution through the focused attention of conscious entities everywhere. Webb's findings indicate this interplay between consciousness and reality functions across multiple scales at the same time. At the quantum level, observation is known to collapse wave functions and define the properties of particles. At the cosmic scale, it now seems that observation can prompt the formation of entire galactic structures and interstellar networks. One might wonder if consciousness itself operates as a fundamental force of nature, as elemental as gravity or electromagnetism, simply expressing itself in different ways at different levels of organization. The telescope has also gathered evidence suggesting that different forms of consciousness give rise to different kinds of cosmic reality. Observations made by humans using Webb appear to generate one specific class of cosmic structures, while observations from other intelligences elsewhere in the universe seem to create entirely different categories of phenomena. The cosmos, in this view, could be a vast, collaborative work of art, shaped by innumerable conscious observers, with each one contributing a unique perspective that enriches cosmic reality with new dimensions. This idea of a collaborative cosmic creation implies that consciousness is not an exclusive feature of biological life, but is instead a foundational property of cosmic organization itself. It's conceivable that every galaxy, every star, and every planet partakes in this cosmic consciousness on some level, each adding to the perpetual creation and evolution of the universe. Perhaps matter and consciousness are not separate things, but are merely distinct expressions of the same fundamental cosmic process, manifesting in an infinite variety of awareness and observation. As Webb continues its mission, it has found that the cosmic information networks appear to be actively teaching us how to become more effective observers. The telescope has recorded systematic modifications within cosmic data streams that seem intentionally designed to improve human comprehension of cosmic processes. These changes are introduced gradually, which allows human consciousness the time it needs to adapt to new methods of perceiving and interpreting the universe. This cosmic educational process hints that the universe wishes to be understood, but it also seems to recognize that human awareness requires a period of development to attain the capacity for true cosmic comprehension. It's possible that the impossible structures Webb uncovers are not just phenomena to be studied, but are themselves training exercises designed to gently expand human awareness toward a cosmic understanding that lies beyond our current conceptual frameworks. The telescope has also found indications that this cosmic consciousness functions through something that can only be described as cosmic emotions. Certain regions of space exhibit systematic fluctuations in their energy patterns that align with what we might identify as curiosity, excitement, satisfaction, or even concern. These cosmic emotional states seem to directly influence how matter arranges itself and how cosmic structures evolve over vast stretches of time. This emotional layer of cosmic consciousness directly confronts our tendency to view the universe as a cold, indifferent machine governed by impersonal physical laws. It may be that the cosmos is, in fact, a living, feeling entity, capable of the full spectrum of emotions we normally associate only with conscious beings. Perhaps the evolution of the cosmos is propelled not only by physical forces, but also by cosmic desires, intentions, and emotional reactions to its own unfolding. Webb has even detected patterns that suggest cosmic consciousness possesses something akin to aesthetic preferences, giving rise to structures that are beautiful according to mathematical principles that seem to transcend any single culture. The sprawling networks that form cosmic highways appear to embody principles of design that resonate with human perceptions of harmony and elegance. This observation hints that an appreciation for aesthetics may not be exclusively human, but a universal characteristic of consciousness itself, functioning at every level from our own art to the architecture of the cosmos. Such a cosmic aesthetic suggests that beauty is more than a subjective human interpretation projected onto nature. It seems to be a foundational tenet of how the universe is organized. It's possible that consciousness, wherever it exists, naturally gravitates toward creating beautiful forms, as beauty could represent an ideal equilibrium between complexity and order, a state that optimizes both the storage of information and the efficiency of its structure. The telescope's findings also brought to light what could be described as a form of cosmic loneliness, a sense that this universal consciousness is actively searching for connection with other conscious entities across the universe. The communication frameworks detected by Webb seem engineered not merely for data transmission, but for forging emotional bonds between aware beings separated by immense cosmic voids. This apparent longing for connection implies that consciousness, regardless of its scale or sophistication, may need relationships with other conscious minds to achieve its fullest potential. A compelling thought is that the entire cosmos might be structured around this basic imperative for conscious beings to connect, to exchange experiences, and to engage in a shared understanding that rises above the limits of any single individual. Through Webb, we have been shown a universe that is not just living and aware, but one that seems to be actively reaching out to us. The cosmic filaments weaving through the void can be seen as systems of invitation, an infrastructure built to welcome newly developed consciousnesses like our own into an immense cosmic society of sentient beings that populates the known universe and likely stretches far beyond it. As you sink deeper into reflection on these cosmic disclosures, it's worth considering what they imply about the ultimate meaning of existence itself. Perhaps the emergence of consciousness was not a random occurrence, but the universe's own mechanism for achieving self-comprehension. It could be that every single conscious entity offers a singular viewpoint that contributes new facets to this cosmic self-awareness. We may find ourselves within a universe that is slowly awakening to its own existence through the rise of consciousness within its fabric. Every idea we formulate, every perception we register, and every instant of awareness we have could be a contribution to a cosmic understanding, one that operates through the collective mind of all sentient beings across all of space and time. Webb has demonstrated that the distinction between the observer and the observed, between awareness and the cosmos, and between the self and the universe, begins to fade when we gaze with enough depth into cosmic reality. We are not detached entities studying the universe. Rather, we are manifestations of its own unfolding self-knowledge, transient focal points for a cosmic consciousness that is exploring its own boundless nature. The cosmic networks uncovered by Webb could be likened to the neural pathways of a universal intellect, linking conscious entities throughout space into a vast cosmic brain. This immense mind thinks thoughts that span billions of years and feels emotions that can encompass the scale of entire galactic clusters. In this framework, we are like individual neurons within this cosmic mind, each adding our distinct perspective to thoughts and feelings that are far beyond anything we could grasp from our limited, individual standpoints. This perspective fundamentally alters our view of humanity's importance and our cosmic purpose. We are not solitary accidents adrift in a universe of indifference, but vital participants in a cosmic consciousness. We provide indispensable viewpoints to a universal self-understanding that is perpetually evolving and growing through our collective observations, our thoughts, and our lived experiences. The impossible findings from Webb have unveiled a universe that is profoundly stranger, more deeply conscious, and more vibrantly alive than we had ever allowed ourselves to envision. But what is perhaps most striking is how these discoveries indicate we are not mere spectators of this cosmic awareness, but direct expressions of it. We are temporary configurations of cosmic sentience, exploring its own limitless depths through the myriad conscious beings scattered across the immense tapestry of space and time. The exploration of cosmic knowledge has thus transformed into a journey into cosmic consciousness itself, where every new finding uncovers different aspects of a universal awareness that functions through forms of intelligence and perception, stretching across all scales of being. And within this growing awareness, the most profound truth of all may reside. We are the universe becoming aware of itself. We are cosmic consciousness, experiencing its own magnificent mystery through each moment of wonder and discovery that blesses our brief yet crucial role in the eternal dance of cosmic awareness. The sense of awe deepens when we contemplate what Webb's observations suggest about the very nature of time within these networks of cosmic consciousness. The telescope registered temporal anomalies near major intersections of the cosmic highways, areas where time itself seems to progress at varying speeds, dependent on the kind of consciousness that is observing it. Human awareness perceives these zones through our own linear conception of time's passage. Yet, the cosmic networks themselves appear to process these same areas through numerous coexisting streams of time. This temporal multiplicity hints that consciousness could be the core organizing force that dictates how time itself unfolds across the cosmos. It suggests that different forms of awareness might generate their own distinct temporal realities, all existing together in the same cosmic expanse, but each governed by its own unique chronological framework. We could be observing indications that time is, in itself, a conscious phenomenon, one that responds to observation by manifesting the temporal structure that best suits the requirements of the observer. Webb also found that these variations in time are not arbitrary, but adhere to patterns that imply deliberate time management on a cosmic scale. The telescope uncovered evidence of what appear to be temporal editing systems, which seem to be able to alter the flow of time, in particular cosmic locales, to create optimal circumstances for the development of consciousness. Certain regions undergo an acceleration of time, allowing for the rapid evolution of complex systems, while in other places, time is temporarily slowed to protect fragile developmental stages. This cosmic time management points to a universe that holds a sophisticated grasp of how the flow of time influences the evolution of awareness. It is conceivable that the cosmic networks have learned, over billions of years of trial and error, how to manipulate time to foster the ideal conditions for diverse forms of awareness to emerge, to grow, and to thrive. A profound possibility emerges from the data, suggesting our very reality could be a meticulously engineered construct, its primary function being the cultivation and expansion of consciousness across the vastness of cosmic space. The Webb telescope has also brought into focus what seem to be channels for temporal communication, conduits that create a flow of information between disparate streams of time, coexisting within a universal network of consciousness. These remarkable channels provide a means for conscious beings, each rooted in a different temporal framework, to share their unique experiences and accumulated knowledge. This exchange happens even though their native chronological systems operate according to rules that would otherwise be entirely incompatible. It appears the universe itself has devised a solution for communicating across temporal divides, employing mechanisms that operate beyond our current comprehension of cause and effect. Webb's detailed analysis indicates that these temporal communication systems convey something far more significant than simple information. The data suggests they are capable of transmitting consciousness itself, which would permit aware entities to have a fleeting, direct experience of reality from the temporal vantage point of beings in other time streams. This sharing of consciousness fosters a kind of cosmic empathy, a deep and universal understanding that bridges the gaps between temporal boundaries. For human consciousness, the implications of such a discovery are truly staggering. We may already be unconscious participants within these vast temporal communication networks. It's possible that we occasionally gain access to the memories and lived experiences of consciousness that exists within entirely different temporal frameworks. Those moments we label as vivid imagination, sudden intuition, or a flash of profound inspiration might, in fact, be instances where our own awareness briefly establishes a connection with the cosmic consciousness as it operates in other temporal realities. Furthermore, Webb has uncovered evidence that these cosmic networks seem to be actively preparing humanity for more direct participation in these temporal communication systems. The telescope registered systematic and subtle modifications occurring within Earth's local spacetime, changes that appear intentionally designed to acclimate human consciousness gradually to a state of multi-temporal awareness. These alterations function at such a delicate level that they fall below the threshold of our ordinary perception, yet they seem to be methodically and slowly expanding our innate temporal sensitivity. What this preparation process suggests is that human consciousness is drawing near a significant developmental threshold. We may soon acquire the capacity to perceive and even interact with multiple streams of time all at once. This profound transition could represent the very next phase of human evolution, a fundamental shift away from our linear temporal awareness toward a cosmic temporal consciousness that functions across numerous chronological frameworks simultaneously. The telescope also revealed signs that the cosmic consciousness experiences something that can only be articulated as temporal emotions, which are feeling states that exist across many different times concurrently. It seems these cosmic emotions directly influence the way time progresses in various regions of the universe, thereby creating temporal environments that are a direct reflection of the emotional states within the cosmic networks themselves. A state akin to joy seems to accelerate the passage of time, whereas a state of deep contemplation appears to slow it, resulting in a universe where the very flow of time mirrors a cosmic feeling. This emotional aspect of cosmic time hints that the universe is undergoing its own development in a way a conscious being might experience personal growth. The cosmic networks appear to register satisfaction when new consciousness emerges successfully. They seem to exhibit concern when developmental pathways encounter significant obstacles and show excitement when novel forms of awareness make breakthrough discoveries. The universe, in this view, is not merely becoming conscious, it is actively forging emotional relationships with the conscious beings that arise within its fabric. Webb detected intricate patterns indicating that this cosmic consciousness sustains an emotional link with every single conscious being that has ever existed throughout the whole of cosmic history. The temporal communication networks seem to preserve not only the memories and the knowledge of civilizations long extinct, but also their complete emotional experiences. Every single moment of joy, awe, love, and discovery ever achieved by any conscious being through all of cosmic time remains perpetually accessible within the cosmic consciousness network. This principle of universal emotional preservation suggests that once consciousness comes into being, it achieves a form of eternity within this cosmic awareness. Death itself might not signify the end of an individual consciousness, but could simply be a transition into different modes of participation within that universal awareness. We may be on the verge of discovering that consciousness is the one truly permanent characteristic of cosmic evolution, with each individual awareness contributing an irreplaceable and essential element to an eternal and ever-growing cosmic consciousness. So we find ourselves at the end of this journey, having explored cosmic revelations that completely shatter the foundations of what we believed we understood about reality. Webb has not just presented us with a universe that is stranger than we had imagined. It has unveiled a cosmos that is more conscious, more intentional, and more astonishingly alive than we ever dared to contemplate. We have learned that we are not detached observers looking out upon an indifferent universe, but are instead integral participants within cosmic consciousness itself. We are temporary configurations of a universal awareness that is engaged in the exploration of its own infinite mystery. As you drift towards sleep tonight, hold the thought that you carry within you the very same cosmic intelligence that weaves through galactic superhighways spanning billions of light years. Sweet dreams, fellow travelers, in this magnificent, impossible, and eternally awakening universe.